Question 4.3. In a titration, the end point was reached when 25 centimeters cubed of an acidified solution containing ethane diuric acid reacted with 20.2 centimeter cubed of 2 times 10 to the minus 2 moles per decimeter cubed of potassium manganate 7. Now, I've been given a volume and a concentration here of potassium manganate 7, so I can get myself a mark at some stage by working out the number of moles. But it also asks for an equation, and the equation I don't know, so I'm going to have to work it out. And with titrations such as this, you have to produce two half equations and then combine the two. Otherwise it's just too complicated to work out. So let's try and work it out systematically. Ethane diuric acid. Do I know the formula of ethane diuric acid? Yes, I do. It's H2C2O4 from the previous question. What do I know all acids make? All acids make H pluses. Well, there's two H's there, so it's going to make two lots of H plus. What have I got left over? C2O4. Now, with a little bit of thought, you could probably work out that it's going to make CO2 and 2 moles of CO2. That's a little bit of applied thinking here to think what might this make? And it makes carbon dioxide. Ethane diuric acid makes carbon dioxide. And then what I've got is I've made two pluses on the right hand side, so I'll need 2 electrons. Remember, half equations need electrons to balance them, because I've got no charges on the left and I've got 2 pluses on the right. I'm going to need 2 minuses on the right to cancel that out. Now, potassium manganate 7 is MnO4 minus. You need to remember that, and you need to remember that it makes Mn2 pluses. So I've got MnO4 minus and I've got Mn2 plus. That's just something you need to learn. From that point onwards, you can work it out. To balance half equations, as well as needing electrons, you'll always need electrons, you can also use H plus and H2O to help you out. If I look at this equation here, I've got 4 O's on the left hand side and I've got none on the right hand side. So where are these O's going to go to? Well, they could go into waters. So I'm going to add some waters on the right hand side. I've got 4 O's, so I need 4 H2O's. The problem then is I've made 8 H's on this left hand side. What else can I use? Well, I can always use H pluses. So 8 H's, so I'm going to need 8 H pluses. You can always use H plus and 8 H2O's to help you balance half equations. Now, let's add up the number of minuses and pluses on the left hand side. I've got 1 minus and 8 pluses. So I've got 7 pluses on the left and I've got 2 pluses on the right. So it doesn't balance. 7 pluses on the left and 2 pluses on the right. I need 5 electrons on the left hand side because 7 pluses and 5 minuses now equal the 2 pluses that are on the right hand side. Now the problem, when I add these two together, I'm going to add everything on the left of this equation, everything on the left of this equation, everything on the right of this equation, everything on the right of this equation. So I'm going to everything on the left and everything on the right will come together to make one equation. So the problem is that I've got to balance the electrons. That's what I do. I create two half equations and then I multiply up to balance the electrons. What number can I multiply them by? Well, I could get these up to 10 electrons. 10 electrons I think is the lowest common denominator. So if I multiply everything through by 5 here, that will get me 10 electrons. So I multiply everything through by 5 and end up with 5 H2C2O4, 10 CO2, 10 H plus and 10 electrons. The other one to get to 10 electrons, well, I've got 5 electrons here, I can multiply that by 2. So I end up with 2 MnO4 minus, 8 times 2 is 16 H pluses, 10 electrons, 2 Mn2 pluses, and 4 waters become 8 waters. Now I add everything together, everything from the left, everything for the left of these two equations. So I've got 5 lots of H2C2O4 on the left with 2 MnO4 minus, 16 H plus and 10 electrons. There it is. And everything on the right, 10 CO2, 10 H plus, 10 electrons, 2 Mn2 plus and 8 H2O. And there it is on the right. Now, can I simplify things? I can cancel the electrons. That was the point of multiplying by some numbers to cancel, get the same number of electrons on each side. They need to cancel. And it looks as if I've got 16H plus here and 10H plus here. So I can take 10H pluses from each side and just leave 6H plus. So now I've got 5H2C2O4, 2 MnO4 minus, 6H plus, 10 CO2, 2 Mn2 plus, and 8 H2O. Without half equations, I would never have arrived at that equation. Okay, so what's next? So now I can work out the moles of potassium manganate 7. So I've got a volume, 20.20 centimeter cubed, I need to get that into decimeter cubed. Centimeter cubed being a small unit into a larger unit like a decimeter cubed, I divide by 1000, so that works out as 0.0202 decimeter cubed. Concentration equals moles divided by volume. Concentration equals 0.2, or 2 times 10 to the minus 2. 0.02 rather. 2 moles divided by 0.202, which is my volume. Moles are these two multiplied together, which equals 0.000404. I've got 0.00404 moles of potassium hydroxide. What am I going to do with that? I'm going to refer back to the previous equation. Now, for every 2 moles of MnO4 minus reacts with 5. Or another way of doing it is 5 moles of ethane diacid reacts with 2 moles of potassium manganate 7. Or I could say 2.5 of those, half the amount, reacts with 1 mole of potassium manganate 7, if that makes things easier. I haven't got 1 mole of potassium manganate 7, I've only got 0.000404 moles. So 2.5 moles of ethane dioic acid react with 1. So if I multiply this number by 0.00404, that's the number of moles of potassium manganate 7 that I've got, by 2.5, I'll work out the number of moles of ethane dioic acid that I've got, 0.00101 moles of ethane dioic acid. Now I've got 25 centimeters cubed of it, or 0.025 decimeter cubed. Concentration is moles divided by volume. Moles is 0.00101 divided by the volume, 0.025 equals 0.0404 moles per decimeter cubed. I have now just worked out the concentration of ethane dioic acid as asked for in the equation.